Hi guys. Today, um, I'm going to take you people into how to solve questions on GATE, questions in GATE for the topics what we have already discussed in the previous sessions. Okay. Let me see how many people are available here. Good evening, Kirti. Good evening, Lokesh. And there are a few numbers again. I can't communicate with you guys if you identify yourself by numbers or something like that. If you log in by using your name or a good way to call you, so that I will be able to communicate with each and everybody who is participating here in the live lecture. So anyhow, hi Kirti, hi Lokesh, the regular customers, the regular people. Okay, today I'm going to take you people into the world of gate questions. Most of you guys might feel that solving gate questions is not that easy. But let me tell you, solving gate questions is our cup of tea. Solving gate questions will not be that difficult if you go through the topic completely and if you listen to the lectures what I have taken here. Okay, so first of all, without wasting any more time, let me give you people some introduction how to solve the gate questions on instruction set architecture, which was the topic that we discussed in the previous sessions. Okay, am I audible first of all? Am I audible? Lokesh and Kirti and whoever the people are available here, there. Am I audible first of all? Just type the message so that I'll be able to continue. Yeah, good. Now let me solve a few gate questions. Good. Kirti, Sai Pravallika. Hi, hello, good evening. Let me tell you in what way we get the questions from instruction set architecture. The current topic that what we're discussing is instruction set architecture, right? Okay. The current topic is instruction set architecture. Instruction set architecture. Yeah. Hi SRB. Fine. Now let us understand in what way the questions can be given here. We know about an instruction format, how the instruction is going to get composed. Okay, in our case we had a 16-bit instruction. Yes or no? Instruction meaning for we guys it's a 16-bit instruction. Instruction is equal to 16-bit. We have divided these 16 bits into three different fields: 1 plus 3 plus 12. Okay, even you guys are listening to the class for the first time, doesn't matter, just stay focused, and if you listen to me carefully, you are going to solve any question on instruction set architecture once we finish the lecture. Okay, so the total instruction size is equal to, let us say for an example, is equal to 16 bits. Okay, in which 1 bit will be given to mode, 3 bits will be given to opcode, and 12 bits are allotted to address of the operand, which means that this first bit is going to give us two modes, right? If I do have a single digit, the digit could be either 0 or 1, in which 0 represents one mode, 1 represents another mode. Let me give you some clarification on this. This is one digit, right? This digit could be either 0 or 1, right? So 0 will be for one mode, 1 will be for another mode. Let me tell you, 0 will be for direct addressing, 1 will be for indirect addressing. Okay, so forget about direct addressing or indirect addressing. If we do have a single digit, the single digit will have two representations. that digit could be either 0 or 1. So we can have two different modes, because first digit I am calling it as a mode digit. So I can have two modes, because 0 will represent one mode, 1 represents another mode, right? So in the instruction, first digit is mode. As it is a single digit, I can have two different modes. Okay. Next three digits, I am calling it as opcode. Okay. If I do have a 3-digit opcode, how many opcodes are possible? Of course, as you guys can interpret, there are 2 power 3 opcodes are possible, right from 000 to 111. Okay. Each combination will represent one opcode. Am I making it myself clear? SRB, Kirti, or whoever you are, Pravalika, SRB, and Lokesh Parab. First, you people participate. So initially, for 5 minutes or 10 minutes, we're going to get all the ingredients to solve the question. Then I'm going to give you guys a question. As you guys solve, I will also solve parallelly. Then we'll compare the answers. Fine? Yeah, good. Now, next three digits are going to give us a 2 power 3 combinations, right from 000 to 111, in which each combination is going to represent one opcode. So there are a total of 8 opcodes are possible in our instruction. Okay, and then least significant 12 digits will give us a memory address, right? This is address of the operand. Address of the operand. Okay, why it is equal to 12 digits? Okay, if it is equal to 12 digits, it can represent an address which is a range of 2 power 12. So the main memory will be equal to 2 power 12. That is, our main memory size is equal to 4096. If the main memory size is equal to 4096, then the address part will be equal to 12 digits. Am I right or wrong? Right? If the main memory size is equal to 4K, then the address part will be equal to 12 digits, which means that the address of the operand will take 12 digits. Altogether, I do have 16 digits here. 1 is for the mode, 3 bits are for the opcode, and 12 digits are for the address of the operand. Okay, in this light, let me compose a question which asks something about the different fields of an instruction. Let us compose a question which is similar to the previous GATE questions. Okay, the question will be as follows. Stay focused, all of you guys, and just understand the question, because the answer will not be available somewhere. Answer we can't get it from the universe or the space. Answer will be available only within the question. So if you could look at and read the question carefully, you will be able to understand the question, and thereby you will be able to solve the question. Okay, Kirti, you're there. Now let me ask you a question. A CPU is designed with 32-bit architecture. 32-bit architecture. Okay, in which the instruction is of one word. One instruction is of one word. Okay, pardon my writing. It is taking some time because There is a huge gap of 15 days, so that obviously my writing goes wrong, goes back. Okay, so here the first statement is a CPU is designed with 32-bit architecture. The CPU size is 32-bit. Okay, which means that one word is equal to 32 bits, right? Yes or no? Kirti, Lokesh, one word is equal to 32 bits because CPU is a 32-bit architecture. In any CPU, the architecture size tells you about one word in the main memory or one word in the register. Okay, the size of the register, whatever. Now, the instruction has 4 fields. 4 fields, namely opcode, two register operands, and an immediate operand. Immediate operand. The total number of registers of registers are 64 in the system. And the number of opcodes are 16. Okay, what is the number of bits in immediate operand field? Okay, this is the question. Stay focused and just listen to me. Now, here the author is talking about a CPU which is equal to 32-bit. Okay, the CPU is using 32-bit architecture. And the instruction is of one word, meaning there are two things that we can get it from here. First thing is the CPU size. What is the CPU size? CPU size is equal to 32 bits. If the CPU size is equal to 32 bits, already you knew that a register size, any register size in CPU and one word size in the main memory are equal to 32 bits. Yes or no? So here we got two things. One word is equal to 32 bits and any register is also of 32 digits. Okay. So which means that instruction register size is also equal to 32 bits. Right? That is, our instruction size is equal to 32 bits. Here we got one more clarification on this. The instruction has, in which the instruction is of one word. The CPU is 32 bits, one word is equal to 32 bits and the instruction is equal to one word. Hence we got something clear, that is instruction size is equal to 32 bits, right? Did I make it myself clear? 16 bits is the answer. 6 plus 6 plus 4 x plus 6 12. Yeah, you got it right. Lokesh Prabh, you're exactly right. But no, let me complete it. You're good. You're correct. Okay, but let me complete it. Instruction size is equal to 32 bits. Till now, you got any doubts? Kirti, is it fine? Did you understand? Pravalika, you there? Did you get every idea that the instruction size is equal to 32 bits? Or Kirti, I'm talking to Kirti. Where is Kirti? Are you there? Sleeping. Yeah, good. Okay, instruction size is equal to 32 bits. Now, what we do is, if you come across any of such kind of a questions, I request you people to draw a block diagram of an instruction. How we do it? Okay, so very simple. This is the block diagram of an instruction. Just draw the size here. This is equal to 32 bits, right? Total instruction size is equal to 32 bits. Here, how many fields we do have? In the question, according to the question, we do have 4 fields. 1, 2, 3 and 4, right? There are 4 fields. Just look at the question carefully. We do have a 32-bit instruction in which we do have 4 different fields. Okay, namely, first one is an opcode. Second one is register field 1. The third one is register field 2. And the fourth one is immediate operand. Okay, which means that I do have 4 fields in which there is an opcode field, register 1, register 2. If you can look at the question, there are 2 register fields, there are 2 register operands and 1 immediate operand. Okay, now we need to identify the total number of bits that are given to immediate operand. So for that, we need to find out how many bits are allotted to opcode, register 1 and register 2, right? So in order to find out the number of bits for the opcode, just see how many opcodes are there. Just find out how many opcodes are there. Okay, here in the question it is given that there are a total of 16 opcodes, right Kirti? There are a total of 16 opcodes. Yes or no? Yeah. Oh, good, great. You people already got it. 16 opcodes. If the opcodes are equal to 16, 4 bits will be for the opcode, right? Because 2 power 4 is equal to 16. As the opcodes are equal to 16, we do require 4 digits to represent any of the opcode. Okay. Then go to the registers. The number of registers are equal to 64. So we do require 6 digits to represent any of the register, because the register, there will be register labeling. How do we label the register? By their number, right? If we do have a 64 number of registers, then we do require 6 digits, right? From 0000000 to 111111. Each and every register will get a unique label in which we do require 6 digits. Okay, so register 1 will be equal to 6 digits. Register 2 will also be equal to 6 digits. So 6 plus 6 is equal to 12. 12 plus 4 is equal to 16. And 32 minus 16 is equal to, for the immediate operand field, we do require 16 digits. Any doubt so far? Any doubt so far? Did you understand this? If there are no doubts, what we do is, I am going to pose one more question on the same data. I want the quick answers. Don't take too much time. Are we done so far? Good. Now, Kirti, you there? Yeah. Look at the same question. I am not going to explain you anything at all. I am done from my side. I am going to pose you a question. Are you ready? Arey, how much time you going to take? Should I ask or not? Fine, whatever. I'm not going to wait for you guys, because I think there is a lap, some lapse, time duration, time gap, so which making you guys taking some time. Fine. The next question on the same data is, what is the maximum size of the immediate operand in the instruction? Okay. What is the maximum size of the immediate operand? Kirti, Lokesh? Whoever listening to my lesson, answer to me. Okay, answer to my question. Immediate operand, the number of bits for the immediate operand is equal to 16. Now my question is, what is the maximum size? Arey, you got... Listen to my question. What is the maximum size of the operand? 16 bits is the field size. I am talking about the operand size. Okay, fine. You did not get it. Let me tell you. Okay, I will come to immediate operand just a short while later. Answer to the question first of all. How many opcodes? How many bits are there in opcode? Answer me. How many bits are there in opcode? I'll come to the immediate operand in a short while. But meanwhile, you just answer to my questions one by one. How many bits are available in opcode? 4. So maximum number of possible opcodes are equal to? Kirti, there are only 4 bits. Opcode, just look at it. Look at it. It's there on the screen itself. Opcode, the number of digits that are allotted to the opcode are equal to 4 digits. Right? Yes or no? So how many opcodes are possible? The number of opcodes that are, the maximum number of opcodes that are possible here is 16. Right? Number of bits in the register field are equal to 6. So maximum number of registers in the system is equal to 64. Right? Yes or no? Similarly, immediate operand field size is equal to 16 digit. Immediate operand field size is equal to 16. Right? And what is the maximum size of the immediate operand? The maximum size of the immediate operand will be equal to 2 power 16, right? Yeah, okay. I'll explain you in a different manner so that you'll be able to understand. What is the size of an integer? Lokesh or Kirti or whoever you are there sitting there, answer me. What is the size of the immediate operand? Sorry, integer in C programming. The size of an integer. The size of an integer, Kirti? Size of an integer in C programming? Size of the integer in C programming is 32K, right? Stay focused, just listen to me carefully. I am going to clear something, that is integer size is equal to 16 digits. Okay, if the integer size is equal to 16 digit, one digit will go for sign. Okay, because the integer could be either positive or negative, so one digit will go for the sign. Rest of the 15 digits are going to represent the actual integer. So if 15 digits are available for representing a value, the maximum value will be equal to 2 power 15, right? Did I make myself clear? That is, one integer size is equal to 16 digits. If it is equal to 16, then it is a signed integer. Of course, obviously in C programming we are going to use signed integer. Signed integer meaning one digit will be allotted for sign. The first digit will be allotted for the sign. Remaining all the 15 digits are allotted for the actual value. If the value is of 15 digits, then the maximum size of the value is equal to 2 power 15, which is equal to 32k. Okay, which is equal to 32k. Similarly, in our case also, maximum size of the immediate operand is equal to 2 power 16. 2 power 16 is equal to 64k. Did I make it myself clear? 2 power n is not correct. See, 2 power 16, you should be precise. Here the number of digits are equal to 16. You already knew it, right? Okay, n value already know. If your perception is n is equal to 16, then I have no objection to take your answer. Obviously what you told is absolutely right and perfect. But here my point is, already n value you know. N value is equal to 16. Immediate operand field is equal to 16 digit, which means that you are going to have a value of a maximum of 2 power 16, which is equal to 64k. Did I make it myself clear, Kirti and Lokesh? Did you understand this? Okay, so once again, let me give you a small recap of the question. In the question, we got a 32-bit architecture system, a 32-bit architecture CPU. When you are given the size of the CPU, immediately you need to understand that the size of the architecture is equal to one word in the main memory. That's it. Okay. At the same time, the size of the architecture is one register size. Okay. It could be any register apart from the address registers. Okay. So our instruction register size is also equal to 32 digits, which means that our instruction size is also equal to 32 digits, right? But anyhow, we are given clearly that one instruction is equal to one word and one word is equal to 32 bits, which is given in the question itself. And there are 4 fields, namely opcode, register 1, register 2, immediate operand. Number of opcodes are equal to 16. Number of registers are equal to 64. Then opcode will take 4 digits, register will take 6 digits each, which leaves 16 bits for the immediate operand. Okay, if you are asked what is the total number of digits for the immediate operand, then the answer will be equal to 16. Or if you are asked what is the maximum size of the immediate operand, then the answer will be 2 power 16, which is equal to 64k. You have to be more precise, use a calculator and just put the exact answer of 2 power 16, that is 64 something. Okay, so you should be sharp enough to give the answers. Okay, because the size of the immediate operand and the number of bits in the immediate operand field are two different questions, right? Size of the number of the bits in the immediate operand field are equal to 16. The size of the immediate operand will be equal to 2 power 16. That's it. Okay, there is nothing else. Okay, good. Now I am going to ask you another question. Can I? Okay. I will ask simply. I don't narrate the question. Simply I will tell you the point so you solve the question. (32-bit architecture). Four field instruction. Fields: opcode, a register, a memory address, and which makes two registers. In fact, there are two registers, one opcode, two register fields, one memory address field. Okay. Number of opcodes, 12. Number of registers, 16. Okay. And what is the size of the main memory? Answer me. This is the question. Here, 32-bit architecture. It is a 32-bit architecture. 4-field instruction, meaning our instruction has 4 fields. Those fields are opcode field, register 1, register 2, and a memory address. There are a total of 12 opcodes. There are a total of 16 registers in the system. Based on these details, you need to find out what is the size of the main memory in the system. See, try first of all. We keep on practicing the questions. Finally, we are going to masterize this topic. Initially, if you go wrong, nothing harm will happen. Okay. First of all, you practice. Without practicing, rather without giving a try, sitting idly is a crime. Okay. After trying, getting a wrong solution is not a crime. That is perfectly fine. Okay. So first you try and give me the answer. Lokesh Parab, Kirti S. Kumar. Lokesh Parab answer is 2 power 20. Kirti S. Kumar answer is Lokesh answer is 2 power 20. Kirti's answer is 2 power 16. Whose answer is correct? Whose answer is correct? Kirti, once again, just go through it and let me know. Why it is equal to 2 power 16? Could you please type there? Why it is equal to 2 power 16? Kirti, just check it out. You got, slightly you did a mistake. If you could correct it, you're going to get your answer right. Yeah, good. Keep that smile always on your face, Lokesh. But Kirti, just check it out. I'm going to give you 1 more minute. After that, I'm going to explain. But anyhow, I appreciate you people. You got in the right track. No matter the answer is correct or wrong. Initially, everybody, even myself, would have gone wrong. But first of all, giving the try is important. Because the number of registers are equal to 12. Okay. What is the answer? 2 power 20. Yes or no? Number of registers are equal to 16, Kirti. Number of registers are equal to 16. Opcode are equal to 12. Okay. Good. Now see here. Opcode is equal to 12. Means that I do require 4 digits, right? Okay. See. Opcodes are equal to 12. If you want to represent 12 different opcodes, I do require 4 digits. 4 will give you 16. But all the combinations will not be used. Anyhow, we do require 4 digits in order to represent 12 opcodes. Okay. If I simply use 3 digits, 3 digits are not sufficient. If I use 4, 4 will be more, but fine. I do require 4 digit opcode. Okay. The next thing is number of registers are equal to 16. So the register field will take 4 digits. So I will write it here. There are 4 fields. 1, 2, 3, 4. First one is opcode. Number of opcodes are equal to how many? Number of opcodes are equal to 12. 12 meaning I do require 4 digits, because 2 power 4 is equal to 16, but 2 power 3 is equal to 8. I can't use 3, I need to use 4. So 4 digits for the opcode. So number of bits for the register 1, register 2, obviously 4 and 4. Okay, so 4 plus 4 plus 4 is equal to 12, and finally the remaining 20 digits are for the memory address. Okay, if the number of digits for the memory address is equal to 20 digits, the size of the main memory is equal to 2 power 20. Yes or no? Fine, you got it. Let us solve one more question. Can I ask you one more question? Yeah, good, fine. Mistake is a mistake. It could be silly or serious. Mistake is always a mistake. Mistakes will always be silly. Fine. 16-bit architecture. 16-bit architecture. Four fields. A mode field, opcode field, immediate operand field, and a register field. Okay. A number of opcodes, 15. Okay. Number of registers, 7. What is the maximum size of the immediate operand if it is a signed integer? Okay, I want the answer for what is the maximum size of the immediate operand if it is a signed integer. That is the question. Again, it's a 16-bit architecture. There will be 4 fields in the instruction, namely one mode field, opcode field, immediate operand field, and register field. There are a total of 7 registers. Okay, there are a total of 15 opcodes, and there is a mode. Okay, direct or indirect. What will be the maximum size of the immediate operand if it is a signed integer? This is a 16-bit architecture. This is 16-bit architecture. Kirti, this is not a 32-bit architecture. This is 16-bit architecture, which means that the instruction is just equal to 16 digit. Right? Lokesh Parab, you're right. I want Kirti to answer. I want Kirti to answer. Kirti, did you get why it is 2 power 7, or should I explain it again? Very good. Of course, it is equal to 2 power 7. Mode will take 1. Opcode will be equal to 15. Sorry, opcode will be equal to 4 digits. Immediate operand the maximum size of the immediate operand, if it's a signed integer, small correction for you guys is 2 power 7 minus 1. I got okay. Yeah, I know. Kirti, I know where you got wrong, because you thought you're still in 32-bit architecture, but we moved into 16-bit architecture. But the answer, a slight correction for both of you guys, is 2 power 7 minus 1, because it will start from 0, right? Did you get it? The answer will start from 0. Sorry, the combinations will get start from 0. Okay, 4 digits will represent 15, not 16, because the first combination will be 0. The 4 digits will be representing a maximum value of 15 only, not 16. Did I make it myself clear? So the answer will be 2 power 7 minus 1. Okay, total 8 digits. 1 digit will go up for the sign. Remaining in the 7 digits, total the maximum size which can be represented is 2 power 7 minus 1. Can you just answer me quickly? So that I'll be able to ask you one more question. Did you understand why 2 power 7 minus 1? Lokesh, answer me. Kirti, answer me. Where are you guys? Good. Fine. Let us solve another question. Understand the question carefully. Kirti, I want you to answer me. Now, look at the question carefully. I don't want you to get into the details immediately. First, you understand what is given, and finally you just give me the answer. Okay. 16-bit architecture. Okay. Yeah, good. 16-bit architecture. Sorry. Instruction is equal to 2 words. Instruction is equal to 2 words. Okay. Here, opcodes are equal to 124. Registers are equal to 64 and what is the size of main memory if the instruction has the following fields. Okay. Instruction has opcode, register 1, register 2, memory address. Adi Lakshmi Curry, I missed old classes. How should I see? You just mail me. I gave you guys my mail ID. You just mail me. So we'll do something. Definitely I'm going to help you guys. Okay. You just mail me so that we'll go forward. Adi Lakshmi. Definitely by the next week, I am going to ensure that you will be able to understand everything. Okay, just mail me. What, Kirti? I did not understand. What is no? What is no? I'm just sending you my mail ID. Yeah, this is my mail ID. Okay, you just can mail me in it. Yeah, Lokesh Barab, is this correct? I don't know. I simply posed a question. Just you see, I did not get into the details. I don't know what I have given also. So, but if it is 2 power 13, then fine. But you can't go wrong. At this stage, I don't want you guys to go wrong. Okay, Kirti. Okay, Adilakshmi. You there? Did you note down my mail ID? Yeah, good. 2 power 13 is correct. Is this correct? I don't know. Let me see. Instruction size is equal to 2 words. 2 words meaning 32 digits, right? 2 words meaning 32 digits. 32 bits. Sir, I didn't get mail ID of yours. Madam, in the chat box, just find out a name, Anil Varsha, that is myself. Okay, I typed my mail ID. Okay, it hasn't come in chat box. Excuse me, Anil Varsha, this is my mail. Didn't you see any name with Anil Varsha? Did you get it? Anil Varsha is myself. Okay, fine. Anyhow, this is a 32 bit. If it is equal to 32 bits, then there are 4 fields. Opcode. Opcode is equal to how many opcodes? Opcodes are equal to 124, which means that 7 digits for the opcodes. There are 2 register fields. Each takes 6 digits each. 6 plus 6 is equal to 12. 12 plus 7 is equal to 19. Of course, memory size is equal to the remaining 30. Didn't you see my name on the chat box? Did you see a name by Anil Varsha in the chat window? Fine, anyhow, I'll type it here. Oh, is it? I don't know then. Fine. anilvarsha.in@gmail.com. This is my mail ID. Is fine? Now is visible? ANILVARSHA .in for India @gmail.com. Now I think it should be visible. Okay, good. Next question, maybe the final question for the day. After this question, you should be completely well aware of how to solve the question on instruction set architecture, especially in this time. Okay, now how I can do this? Yeah, a computer system, rather a CPU, a CPU, a CPU uses fourteen opcodes, 14 opcodes, rather sorry 64 opcodes, 64 registers. The CPU uses 64 opcodes and 64 registers. It also uses a wait not 14-bit 16-bit immediate value. It also uses a 16-bit immediate value. Okay. Instruction has an opcode, 2 registers, and one immediate operand. Okay. The question is, how many bytes are needed for instruction? This is the question. A CPU uses 64 opcodes and 64 registers. It also uses a 16-bit immediate value, and an instruction has an opcode, 2 registers, and 1 immediate operand. Okay. In order to compose this instruction, how many bytes does this architecture require? Okay. How many bytes does this architecture require? This is the question. Can you answer me? No, wrong. Just stay focused. It's the simplest question. Only the thing is, you just have to think in the right direction. That's it. Kirti, 4 bytes. Could you please explain me, Kirti, why it is 4 bytes? Why it is 4 bytes? I'm waiting. You just type it. I'm going to, look at the chat window. I'm going to see your chat window. You just tell me why it is equal to 4. Why it the instruction requires 4 bytes. First of all, how many bits are given to the instruction, and how 4 bytes? What is 2.75? Lokesh Parab, there won't be any half measures in a byte. If you want to take a byte, take a complete byte. There is nothing called a half byte. Okay, a byte is equal to 8 bits, in which you can't cut a piece. Okay, of course, sometimes in 8086 you might have heard about a nibble. Only that is for our understanding. Even if you want 1 digit, let me tell you, you want to store 1 digit. Can you separately store that one digit in a single flip-flop? No. Even if you want to store one digit or two digit, you need to take a complete byte. Okay. You want to use only 4 digits in the byte, doesn't matter. Still you need to obtain a complete byte. Did I make it myself clear? Okay, for an example, Kirti, 16 bits are not given. Your answer is wrong. Let me tell you. Okay, I will solve this question for you. So stop thinking about solving this question and just listen to me. Okay, I'm gonna not write anything on the screen. Rather, I'm gonna explain you orally. I want to make you people thinking. Just give your brain some work, some task. Let it get sharpened. A CPU uses 64 opcodes. 64 opcodes meaning opcode is equal to 6 digits, right? Opcode is equal to 6. No. I am not allowing you people to answer. Your time is over. Okay. Opcode is equal to 6 digits, right? Yes or no? There will be only one opcode. The registers will also be equal to 6 digits, right? So opcode is equal to 6 and there are 2 registers. Each register will take 6 plus 6. 6 plus 6 plus 6 is equal to 18. Yes or no? 18, if you take 18 digits, it comprises one opcode, 2 registers. Okay. In addition to this, I do have an immediate operand. Immediate operand is directly given. We don't need to calculate the number of digits that are required for the immediate operand. Immediate operand field is equal to 16 bits, which is directly given by in the question itself. So the total number of bits in the instruction is equal to 34. Yes or no? Total number of bits in the instruction is equal to 34. Okay. 34 meaning how many bytes we do require, sir? 34 meaning 5 bytes. Okay. Actually 32 bits requires 4 bytes because 4 8s are equal to 32. But I do have 2 additional digits. Can you manage and organize 2 digits separately? No. As I told you just a short while ago, even you require a single digit, we need to obtain a complete byte. Okay. Here the classification is, the division is 6 opcode, 6 register, 6 one more register, which will give you 18. Okay. Plus 16 digit immediate operand, which will give you a total of 34 digits. Okay. 34 digits meaning 4 bytes plus 2 digits. 4 bytes are equal to 32. But we do have 2 additional digits. Can we organize 2 additional digits separately? No. Even if you have 2 additional digits, I do require a complete byte, which requires a total of 5 bytes in order to compose this instruction, in order to accommodate this instruction. Did I make it myself clear? Did I make it myself clear? Why do I need 5 digits? Kirti? Lokesh? Where is Adilakshmi? There is nobody is here and I think she left already. You got an answer? Did you understand it, Kirti, Lokesh? Good. Okay. So we are already done with instruction set architecture. The major questions from the the maximum question from the instruction set architecture from this model, take it for granted. You are going to solve one question in GATE 2021. I am going to give you a guarantee. Okay, just practice more and this D type. Just simply we need to manage the bits. That's it. If you could understand this, we are done with one model in the computer architecture. Okay, I think we are done for the day. Next week, same day, same time, next week. Okay, thank you so much. We're gonna meet in the next Friday. Good evening and good night.